Hello and welcome to Science Never Stops. I'm your host Joseph Vick with the U.S. Space and Rocket Center with today's topic, Earth, Moon, and Mars, distances and scale. So with scale of the solar system, I actually drew out the solar system here. So our solar system consists of one star we call the Sun, 8 planets that orbit the Sun, and endless discoveries yet to be scientifically discovered. So with this scale, I have drawn all of the planets and a little bit of the Sun and the asteroid belt on this small sheet of paper. Now, the solar system that we are in is much, much bigger than this sheet of paper. So what I took was materials and put them on a sheet of paper in a smaller scale or size related to what is the big picture. So that is what scale is in a sense. If you draw something out in one sheet of paper that is much bigger than that sheet of paper, you are lessening that scale to show a bigger picture. And to put into perspective when you're looking at scale, you need some measurement amount to know what you're looking at. So with this, I added to the scale. So from the Sun to our island home, our planet home there, the Earth, that distance is 93 million miles, or 1 astronomical unit in scale. So that small little amount, which looks to be about 1.5 inches on this piece of paper, is 93 million miles. So our solar system is really big and expansive, as well as all the cosmos. But let's break it down into just 3 of these bodies in our solar system, which are Earth, our planet home, our neighbor the Moon, and our neighbor Mars. So we wanted to do a set scale and find certain things around the house, and to do that you can do this scale using a quarter, which I have painted blue, which you can do as well, which this would represent the Earth, a dime, which left silver will represent the Moon, and a nickel, painted red, which then will represent the planet Mars. And these are to scale size. If we were to shrink down the planets, you would have them in this sort of size comparison to one another, as a quarter, a dime, and a nickel. Now, the quarter, again, represents Earth, and with Earth, on the quarter, notice it has the ridges on the side. Those coarse ridges represent the furthest low Earth orbit distance. So one of those ridges, the very tip top, imagine the International Space Station, a very tiny little speck on top of one of those ridges. That would be the ISS, or International Space Station, resting an orbiting spot around the Earth. Over NASA's 60-year history, the majority of astronauts have actually been in that part of outer space. So that's the majority of our human exploration area around our Earth, low Earth orbit. Now, there have been more astronaut discoveries where they go outside of that, but that area which is at that ridge, which represents about 250 miles straight up, which would be the distance roughly of driving from Rocket City, USA to Orange Beach down in South Alabama. So that's just straight up. There's still a lot of discoveries to be found there. I'm not at all discrediting any of the astronauts that go up there, because this is science. This is what we're doing. We're observing Earth. We're discovering things that we've never discovered before in a space station. But NASA's next big leap is deep space exploration. Now, 50 years ago, NASA sent 9 groups of 3 men, and were only 12 of them walked on this next piece, our closest celestial neighbor, the moon, which is representative with the dime. So you have the moon and the Earth system, which you have the moon going through the phases as it orbits around the Earth. And this would be the relative size scale to one another. Now, size comparison scale, but what about distance scale? What would you say would be the distance based on these sizes representing Earth and the moon? Do you think they would be separated from one another? Would they be this close? A little bit further? What do you think? Write down what you think your answer is. And in truth, it would need to be, get my ruler or my handy piece out, not 1 foot, not 2 foot, but 3 feet long, which would be almost a meter in length and distance. So that means you would need to put the Earth at one end and the dime at the other to have the exact scale that we would have when we step outside in our backyards, look up at the full moon, we would know that that would be the scale distance. Now the actual distance is around 240,000 miles, or 390,000 kilometers in distance, which is quite a ways. And when we sent the astronauts in the Apollo program there, it took us about 3 days travel to get to the moon, with a day or so traveling and exploring on the surface of the moon, and then about 3 days returning back to Earth. So it takes us quite a distance to get there, quite some time to take and travel those 240,000 miles, or 390,000 kilometers from Earth to the moon. Now, NASA is currently working on the next great ship, the Space Launch System that will be taking us back to the moon, to the southern pole region of the moon, and they will be sending more astronauts, male and female, to explore places we never have on that lunar surface. Now, our next closest, past the moon, we have planet Mars. So we have been looking at Mars since ancient times. Even the ancient Egyptians would look up and see this sparkling red dot in the sky. And this was Mars. Mars we've sent lots of robots to, exploring the surface still today. And still soon to send another rover, the 2020 rover Perseverance, to explore even further the surfaces of Mars in 2020. So we have here Mars, the red planet. Where do you think Mars would land on this scale as compared to Earth and the moon? If we're going to line those up, we already know this distance apart is 3 feet, or roughly a meter. Where would Mars fall on this same scale? Write down your educated guess down in your journal. Do you think it would be another 3 feet? Or we could maybe double it, 9 feet? What would you say if on this scale, with the quarter, the nickel, and the dime, the nickel being Mars, you would have to stretch out your measuring tape to 500 feet, or 152 meters. Mine only goes up to 12 feet, so mine doesn't stretch that far. But 500 feet you would have to walk or drive in order to get the full scale distance from how far Mars is from the moon and the Earth system. Now, that would wear me out. So for this video, we're not going to drive off or walk out 500 feet. But note that that's a really long distance to get there. Now, to go to the moon, it took us 3 days. Going there in an Apollo capsule and returning in 3 days. Us planning our trips to Mars, sending things to Mars, we have to send it to Mars when it's closest to the Earth as they are rotating, orbiting around the Sun. We do this because it saves on fuel and it's closer. The closer it is, the faster it is to get there. So with this distance, we have to consider that while we travel in reality, which is that its shortest distance, 34 million miles, or 55 million kilometers, it will take us 6 months to get there. 6 months, half a year. And then when we get there, we're not just going to spend a few days, because 6 months worth of travel, we want to establish ourselves, explore quite a bit, and then returning back to Earth from our mission, it'd take another 6 months. So you're looking at a year, 2 years, 3 years for our travel to Mars. So deep space human exploration is difficult. But, in the words of President Kennedy, we do these things not because they are easy, but because they are hard. Science is not easy and it's hard, but because of that hard work, we discover great things. We do great things, and we do it because it's fun. We do it because science is fun, science is challenging, and it provides for us great things as well. So I encourage you to make your own Earth, Moon, and Mars scale distances, and you can have these as your own little lucky charms to carry around with you, and you can describe the scale and distance and have your own small little solar system in your pocket. So remember, learning is fun, learning is exciting, learning makes sense, and science never stops.